Before we start working in Unity, it is beneficial to understand why animation works, because essentially it is an optical illusion. The earliest theory was called persistence of vision. It refers to the way multiple individual images merge into one when presented in quick succession in front of the human eye. It was thought that after an image was seen, that a small imprint of that image remained on the back of the eye. When each successive image had a small change made to it, the illusion of movement was perceived. Or so they thought. This original theory as to why the human brain processed images detected by the eye in this way was disproved in 1912, though many animation and film theorists still reference it. There are two other phenomena that are thought to produce the illusion of movement required for animation. These include the phi phenomena and beta movement. Where phi phenomena is the apparent movement perceived by luminous sequential impulses, beta movement is caused by stationary luminous impulses. Confused? They sound like the same thing, but physiologically they are different. The phi phenomena occurs when lights are turned on and off in succession, giving the illusion of movement. In this example, the red light appears to be moving around the square, but in reality it is just a colour change in each following cube colour. On the other hand, beta movement is what occurs in animated sprites, and the effect that allows us to watch films that are recorded frame by frame. And yet when played back at the right speed, our brain considers it as a continual animation. In this example, you can see the dragon character is a cartoon consisting of 12 frames. When played back, Unity by default plays it at 12 frames per second. The threshold frame rate at which the human brain sees smooth animation is between 10 and 12 frames per second. Any slower and it will look jittery as the eye becomes aware of each individual frame. Animation playback inside a game is affected by the amount of processing the game needs to perform in order to operate. The animations are just a small part of the tasks a game engine needs to perform as it renders each frame to the screen. The more models, animations, sounds, special effects, and artificial intelligence in a game, the harder the engine must work. The more processing, the slower the frame rate, as this demonstration shows. As the amount of balls filling the scene increases, the frame rate drops.